let's make this an asynchronous method. I'm going to inject an iSender so that I can send a respective mediator query. So let's add the iSender dependency, and then we're going to say var result is equal sender, and then let's send a new get ticket type query. This requires a ticket type identifier and a cancellation token. The result is a result object of the ticket type response. And of course, I should have made the events API nullable because we may not find the respective record in the database. So if the result is failure, we're going to return null from this method. Otherwise, let's return a new ticket type response, and then let's map the value from our result. So I'm returning the ID, the event ID, the name of the ticket type, the price, the currency, and the quantity. I'm going to update the file name of my events API class, or rather I'm going to move it into its own file and update the file name of the ticket type response. And then let's register this as a scoped service in our events module. So I will say services, add scoped, iEvents API, and then the events API implementation. And now we can go back to the add item to cart use case and implement the second step. So now let's look for a ticket type. We need to inject another dependency. There's going to be the iEvents API. We don't have a reference to this, so we're going to add a project reference to the events public API project. And now I can add this as a constructor argument. Then I will say await events API, and then I will look for a ticket type in this module, and I can pass in the ticket type argument. This is going to return a nullable ticket type response. And again, if ticket type is null, let's return a failure, and I will say ticket type errors not found, and let's specify the request ticket type ID. Finally, it's time to create a new cart item. So let's say new cart item, and we need to set some properties on this object. First of all, we need to set the ticket type identifier to ticket type ID. Then I need to set the price, for example, and these are all values coming from the ticket type. Let's set the quantity to our request quantity and the currency to the ticket type currency. Now I can use my cart service and call the add item async method, and we can specify the customer ID, the cart item, and the cancellation token, and we have successfully added the item to the cart. So you can see that our use case is more or less straightforward, but it's requiring some synchronous communication with the other modules in our system. And this has quite a few implications. In this case, we need to talk to two different modules to fetch the required data. Imagine if this was a more complex use case and we needed much more data, how many additional calls to the other modules in our system would we need to make? This is why I prefer implementing an event-driven communication approach between my modules and copying the required data inside of each of the modules. This also makes the modules self-contained, whereas in this case, our ticketing module is very dependent on the users module and the events module. Let's expose an endpoint in the ticketing API to add an item to the cart. So let me add a new folder inside of our presentation project, and let's call it carts, and I'm going to add an add to cart class inside. If we open up this class, you will see that it's calling the add item to cart command, it's sending it to the application project, and it's returning a respective result. The request contains the customer identifier, the ticket type ID, and the quantity. We are also missing the tags static class that I will add to the root of this project, and you can find the source code for both of these classes under this video. Now that our endpoint is in place, let's give our use case a try. I've created an event with two ticket types. It has the regular and the VIP tickets. If I send this query again, you will see that we get back the two ticket types. So let me take the identifier of one of these ticket types, and I'm going to call the add to cart use case and specify the ticket type identifier. This is already pointing to an existing customer in the database, and I set the quantity to 5. So let's go ahead and send this request. You will see that we hit the breakpoint in the add item to cart command handler as expected. And now we're going to call the users API to see if we can find the customer with this identifier. If I step into this method, you will see that we are now in the users module, and we are sending the get user query to get back the user's information. Because this is successful, we're going to return a user's response and pass the null check. Then we're going to do the same with the events API, and now we are inside of the events module. Remember that all of this is synchronous communication, so we are using request response, and even though we are sending commands and queries, this is still just doing method calls in memory. So in this case, we also found the ticket type and we can return it to our use case. Finally, we are ready to create the cart item. We're going to create a new instance, and then we will use our cart service to see if there is already a cart for this customer. And you can see that we do get back a cart. Now, does an item like this exist? Well, you can see that the return value is null. So in this case, we're going to be adding a new item to the cart. And once all of this completes, we're going to save the item to the cart using the cache service, which is going to store the value in Redis, and we can complete our add item to cart use case. And you can see that we get the response back in Postman. I can send this request again now, and this time it will just be increasing the quantity of the specific ticket type in my cart. And with this, we can wrap up the simple implementation of synchronous communication between our modules. The respective modules, in this case the users and the events module, are exposing a public interface which represents the public API of these modules. The interfaces themselves are defining what are the methods that we are allowed to call inside of this module, and we don't have access to anything else other than what is exposed in the public API. Also, the calling module, in this case the ticketing module, is only allowed to reference the public API of the other modules. If you recall, I stressed this many times in the module constraints chapter. A few other implementations of this that you will see is, instead of exposing an interface for the public API, you could expose a query object or request object as the public API and then handle that internally using Mediator, but effectively you are still using method calls in memory, even though you are leveraging the Mediator library to kind of hide the fact that you are still doing request response, which is why I prefer this simpler approach to just create an interface with the required methods, implement that internally inside of the defining module, and then in these methods I can use whatever I think is the best tool for the job, because I will most likely already be implementing that use case inside of the application layer. The simplest approach would be to just send the respective query and map the result of that query to the required response. And with this, I'm going to wrap up the initial implementation for synchronous communication between our modules. I showed you how to define a public API for your modules, implement it internally inside of the module, and then use it from another module to obtain the required data. In the next lesson, I'm going to discuss duplicating data between modules, but we are still going to be using synchronous communication to achieve this.